Hello, this is Mr. Henry, and welcome to lesson 4.6. Today we're going to be talking about direct variation. So the essential question says, how do I write and graph direct variation? We have a couple get the goofs here, where in each of the questions they want us to find the slope and the y-intercept. So let's see how we do. Number one. Well, this is written in slope-intercept form. Y equals slope x plus that. So that is the slope. That's almost the y-intercept. The problem is this should be a negative 9. Then it would be the y-intercept. Number 2, you cannot just say that that is the slope and that's the intercept. It's not always just the thing next to the x. This has to be written as slope-intercept form first. So it has to be written as y equals mx plus b. It's not. This does not have the y equals and everything else on the other side. So to do that problem, we have to get that. So this would be minus 4x minus 4x. You get a negative 2y equals negative 4x plus 6. Divide by negative 2, divide by negative 2. These cancel. Y equals 2x minus 3. Now we have it in the correct form. See, y equals mx plus b. This is the slope. This is the intercept. Number 3. Well, this actually does kind of look like this. We're just missing a piece. We're just missing the intercept thingy. So this is the slope. That's correct. But as far as the intercept, none? Not really. I mean, we could always make this thing a plus 0, and this is still true. I mean, 1/5 x plus 0 is still 1/5 x. And so the intercept is not none. It's actually 0. This third example is a good example of what we're actually doing today in this lesson. So we have two vocab words. We have direct variation. And direct variation is when two variables show direct variation if y equals ax. So to relate to something we've seen before, y equals mx plus b and y equals ax. These guys are almost the same. I mean, y equals, you have to get the y variable by itself, y equals some number x. One of the major differences here is that this slope-intercept form has a y-intercept, where here the y-intercept is going to be 0. Because you could always just add 0 to something and it doesn't change the problem. So if we have this y equals ax, this plus b will be a plus 0. So this guy always goes through the origin. And this constant of variation, in this formula, it is the a. In this case, it's our slope. M, A, same thingy. It's the slope of the line. Okay? So this is a lot like what we've been doing. We want to get any of the equations as y equals. The intercept is going to be 0. We graph it, and the slope of the line is this constant of variation. Okay? So the first thing they want us to do here is they want to tell us whether this is direct variation, yes or no. If it is direct variation, what is the constant of variation? So first things first, we have to get y by itself. So we're going to solve for y. No parentheses, no exponents, no same variable on both sides. I do have this thing being added or subtracted to my y. Yeah, so I have to get rid of this. So I'm going to add 2x to get rid of a negative. Okay, let's see here. This has an intercept of 0, which means this is direct variation. So yes, direct variation. And since it is direct variation, they want us to figure out what is the constant of variation. And we said the constant of variation is the slope. Well, the slope of this line is 2. That's it. That's all we really had to do for that problem, is find, is it direct variation? Yep. What is the constant of variation? 2. Okay, letter B. We have to get the y variable by itself again. So we're going to start by subtracting x. 3y equals negative x plus 9. Again, we like the x first because we want it to look like slope-intercept form. So y equals mx plus b. So we put the x thingy first. To get rid of a times by 3, we divide by 3. Cancel. Y equals this. We can't actually divide it, so we're going to leave it as the fraction. Negative 1 divided by 3x. This does divide, so let's divide it. Alright, so y equals negative 1/3 x plus 3. Is this direct variation? No, because this does not go through the origin. This line, whatever it looks like, it's kind of a negative slope, it goes through positive 3, up here someplace. It's only direct variation if this piece is 0, which means it goes through the origin. Okay? Now, I'd like you to please try letters C and D. Same thing. Find out if it's direct variation. If it is, what is the constant of variation? Go ahead, pause the video, do the problems. When you're ready to continue, hit play and we'll go through them together. Okay, so let's see how we did. First off, we're going to start by solving for y. Get the y variable by itself. So I'm going to minus 2x minus 2x. Remember, it's a positive 2. It's a negative 3. You don't read problems right to left. These cancel. We get negative 3y equals negative 2x. Divide by negative 3, divide by negative 3. These cancel. Y equals, this does not come out to a pretty number, so we're going to leave it as a fraction. But it's going to be a positive 2/3 x. And if you really want to add the plus 0, you can. So is this direct variation? Yes. It goes through the origin. The intercept is 0. And the constant of variation is the slope, and it's 2/3. Letter D. Solve for y. So we're going to add x to get rid of the minus x. Y equals x. Got this 4. The y is by itself, so this is done. Is this direct variation? No. This has to be 0. So that's the first part of the problem, or the first part of this lesson, is just identifying if something is in direct variation and finding this constant of variation, which is the slope. Okay? Please answer this question in a sentence or so. How do you know if the equation represents direct variation? Think about it, write down your answer, pause the video. When you're ready to continue, hit play and we'll go through it together. Okay? I said something like, you can tell if the equation represents direct variation if the equation is in slope-intercept form, and the y-intercept is 0. And I guess one other thing that is kind of important to mention. It didn't really come up last in the problems that we did. That slope, as we said, slope-intercept form, the y equals mx plus b, and we said like that's the constant of variation. That thing cannot be 0. So that's really the only other important thing to mention here. So the slope can't be 0. And I think it goes without saying, it can't be undefined either. You have to have a slope. All right. Now, I'm going to give you 3 problems to try out of the textbook. They come from page 253, numbers 1 through 3. In each of the problems, you're doing the exact same thing we did. Is it direct variation? If it is direct variation, what is the constant of variation? So please do these problems right now. When you are ready to continue, hit play, and we'll go through them together. Okay, let's go through them. Number 1, we're going to add x to both sides. Y equals x plus 1. That is not direct variation because this does not go through the origin. It has a y-intercept of 1. Number 2, let's see, we're going to subtract 2x. Y equals negative 2x. This is direct variation because we can add this plus 0 to make our intercept. So it is direct variation, and the constant is the slope of negative 2. Number 3, let's see, solve for y first. So we have to minus 4x, get a negative 5y equals a negative 4x. Divide by negative 5, cancel, divide by negative 5, we get y equals a positive 4/5 x. So, is it direct variation? Yes. There is no there's no intercept. It's just plus 0. So, yes, it's direct variation. And as far as the constant of variation, it's the slope of 4/5. Pretty easy problems. Now the next thing we're going to do, hopefully you've seen on your note sheet, is we're going to actually graph these. So here we're given an equation. Now we do not need to make an xy table. We can actually use the same idea we were using with the slope-intercept form. So in this equation, we have the y equals mx plus b. Remember, in direct variation, the intercept is always 0. You can add plus 0 to any problem, ever, and it will not change the problem. So this plus 0 is just to help us identify what we're doing. So now when we graph this, like we did in the last lesson, we start by putting a point at our origin, at our y-intercept, and then we move the way the slope tells us to move. The slope says we're going to go positive 2 in y, positive 3 in x. So I go positive 2 in y, positive 3 in x. And repeat it. 1, 2, 1, 2. Phooey, I'm out of space. It'd be over there someplace. But we can also do the reverse of it. Instead of going this way, do the exact opposite. Go down 2 in y, over 3 in x, the other way. Do you see how it still makes a nice straight line? That's because it's the correct spot. Okay? And that one will be off over there someplace too. So now we have our points. These 3 in the middle are good. These 2 on the outside are just kind of estimations, but ugh. Apparently I'm not very good at drawing lines today. Something like that. So that is the graph of this line. It has an intercept of 0. That's the slope. Okay, let's look at the second one here. Well, we can add this plus 0. And so this line is going to cross the origin, the y-intercept, at 0. we want this to be a fraction. We always want our slopes to be fractions when we graph. It makes it much easier. So we can put this over 1. That's how you turn any whole number into a fraction. You put it over 1. So now, this slope says we're going to go down 3 over 1. Down 3 over 1. Now, we can't go down 3 over 1 anymore, so now we just have to do the reverse. So we're going to go up 3 over 1 the other way. That is our line. Let's make sure we get a nice pretty line this time. It's prettier. That is the graph of this y equals negative 3x. It went through the origin with a slope of negative 3. Okay? There's one I'd like you to try, please. So there's letter C. Please do the problem. Pause the video. When you're ready to continue, hit play, and we'll go through it together. Okay, so we have y equals, this is our slope, that ooey, plus b. But instead of b, we can actually put in a number. We can put in 0. So this line is going to cross the y-axis at 0, right there in the middle. And a slope of negative 2/5. We're going to go down 2 over 1 over 2 over 3 over 4 over 5. So we went down 2 over 5. Remember, treat the negative like it's with the top number. It makes it easier, just so it's always consistent. So you just go down 2 over 5. And then, because we don't have spacing over here anymore, let's do the reverse. So we're going to go up 2 over 5 the other way. 1, 2, 3, 4, 5. Does that look like it's in line with those other 2 points? It does, which means it is correct. Now, we draw a line. Let's see, something like that. It's close. You can use a book edge or something straight, a folder, whatever you need to do to make sure your lines are as straight as possible. There, that's a little bit better. So we have a negative 2/5 slope going through the origin. It's direct variation because it is going through the origin. That's what makes direct variation. Now, in this third example here, what we're going to do is it gives us a graph, and we are going to come up with the equation for the graph. So let's see here. Write an equation, blah, 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 blah. So here's my graph. We need to write an equation for that. Well, first off, we want it always to be in the form y equals mx plus b, slope, intercept. Well, we know here that the intercept is going to be 0 because it's going through the origin. The slope, on the other hand, we can do this. Remember how we did this using the points and doing the y2 minus y1 over x2 minus x1? Well, there's an easier way if you have a graph. We can actually just count. So first off, find your crisscrosses like we did before. There's one there, and one there. Now watch. From this point here to the next one, we'd go up 1, up 2, up 3, up 4, over 1. Up 4, over 1. So this would be our graph. It's actually y equals 4, that's just this simplified, x. The second part of the problem says find the value for y when x is 12. So if x is 12, what is y? Well, that's just a simple little bit of math. We take 4 times 12 and we get y equals 48. So if we actually go over here to 12 in the x value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, the y value up there would be like 48. Really big number. Okay? So we want it like this. We know the intercept is 0. The slope, we can count from our picture. We should find the change in y, it's the top number. Change in x is the bottom number. Simplify if need be. That's your equation. And then it said plug in 12 for x. We did. We got the math. We good. Letter B. Same deal. Write the direct equation or the direct variation equation, then find the value for y when x is 12. So slope x plus b. So here's my equation. Let's see. So we know the plus b is plus 0. That's the origin. The line's going through this y equals 0 part right here. Okay, there's a crisscross, and there's one, and there's one, and there's one. It does not matter what you pick. You're just going from one dot to the next one over. So I could use this two, or those two, or those two, or those two. Just for difference, I'm going to use these two over here. So from this point here to this point here, what would you need to do? Well, first off, the change in y, the up and down, I need to go down 1. Down 1. That's how you show going down. It's a negative. So you go down 1 over 2. So down 1 over 2. The slope is negative 1/2. And we can double check it. Look, the next point. Down 1 over 2. Down 1 over 2. Down 1 over 2. So the equation y equals negative 1/2 x. Now it says find the value for y when x is 12. So if x equals 12, what do we get? Well, if you've got a nice fancy handy-dandy calculator, you can plug that in. Or if you've got a nice sweet brain like mine, 12 times negative 1/2 is a negative 6. And we're done. Okay? So, I would like you please to do the next two problems out of the textbook. They come from page 254, numbers 4 and 5. Number 4, you're going to graph this. Number 5, it gives you a little wordy problem, but you still might need the graph space to do it. So please do numbers 4 and 5 from page 254. Pause the video when you're ready to continue, hit play, and we'll go through them together. Okay, let's see how we did. So number 4 here, we want to graph the equation y equals 2x. So the intercept is going to be 0. The slope is going to be 2. As a fraction is 2 over 1. So from here we're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. I'm out of space. I go the opposites. Down 2 over 1 the other way. Down 2 over 1 the other way. It makes a nice straight line. And we're done. That's number 4. Number 5. Graph the direct variation equation. The graph of a direct variation equation passes through the point 4, 6. Write the direct variation equation and find the value of y when x equals 24. Okay, so we can do this a couple ways. We could do this using the graph, and we can plot that point. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it goes through that point. Do we know where else this graph would go through? Well, it has to go through the origin. That's what makes it a direct variation equation. Okay? And then, if you imagine a line going through here, yeah, something like that. There. That's about what it would look like. So now we can find the slope. We find the crisscrosses. Let's see, there's one there, there's one there, there's one there, and there's one there. So in that form y equals mx plus b, we know the plus b is a plus 0 because it goes through the origin. The slope, From one point to the next, you would go up 3, up 3 over 2. Now, if you did not have graph space, or if you did not make a graph, so let's get rid of them and him, we could do this the old-fashioned way. It gives us this point and says, what's the equation? Well, remember, the only really number you need here is the slope. Well, given this point and knowing the other point is 0, 0, watch this. X, Y, X, Y. We'll call this point 1 for no other reason. This point 2. Then you do M equals 1. No, what am I doing? 1/2. M equals y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. That gives you 6 over 4. That simplifies to be 3 over 2, which is what we got when we did the counting. Okay? So either way you do this, we're in agreement that the equation is y equals 3 over 2x. Now, it then says, write the direct variation. Okay, we did that. Find the value of y when x is 24. So now we have to plug in 24 for x. And do the work in your head or on a calculator. Let's see, 3 times 24 is 72. And then 72 divided by 2 is 36. But just to double check it, 3 times 24 divided by 2 is 36. And we're done. Okay. The last type of problem we're going to see here is looking at a chart. Instead of looking at a picture, we're going to look at a chart and figure out, is this thing direct variation? Now, so it gives us some just general information like number of songs, cost. We want to know, does this represent direct variation? Okay. So first thing we're going to do is think about this as our x and there's our y. So in each case, we actually need to check all of these. Is the change in y over the change in x? The change in y over the change in x. Y over x. I'm taking this as our slope, the y value over the x value. And I want to know, are these all the same? If we find some that are the same and some that are different, it's not direct variation. They all have to have the same slope. Okay, so let's do this math a little bit. This is definitely calculator math. So clear, clear, clear. 2.97 divided by 3 equals 0.99. Okay, next one. 4.95 divided by 5 equals 0.99. Alright, last one. 6.93 divided by 7 equals 0.99. All 3 points here had the same slope. So if we were going to write this equation, y equals mx plus b, we know this part is 0 because it's direct variation. It tells us so. And we know the slope is this 99 cents, so 0.99. So we get y equals 0.99x. And you don't really need this plus 0. So that is the equation. We found the slope by putting the y value over the x value. We checked all 3 of them to see if it was the same. If, for example, we would have got this one to be 0.89, then this would not be direct variation because then our points would not all be the same. We might have like points like this where it does not make a straight line. There's one point that's off. Letter B. Same deal. So we're going to take the y value over the x value, y value over the x value, y value over the x value, y value over the x value. And we're going to see if these are all the same. Well, 2 divided by 1 is 2. 4 divided by 2 is 2. 5 divided by 3 is not 2. So there's a problem there. Something's wrong there. And this should be a 4. 8 divided by 4 is 2. So this guy is not direct variation because this one did not work out. That does not have a slope of 2 when all the other parts do. So all we can really say is not direct variation. Because this guy does not have the same slope as everything else. Again, you want, if you have a graph like this guy has a slope of like 2, something like that. If a couple of the points are here and you get one point that is lower, like that, well, he's not on the line, which makes this set of information not follow direct variation. Please do letter C. When you're ready to continue, hit play, and we'll go through it together. Okay, I'm going to start doing it now. If you haven't done it yet, please go through and do it. So you get negative 3 over 1. I lied. Backwards. Y over x. 1 over negative 3. Y over x. Y over x. So let's see. This is, well, that doesn't simplify. This is not even allowed. That's undefined. This is equal to 1. Did we get the same slope in all three of them? Heck no. This is not direct variation because we did not get the same slope with each of them. Okay. Last problem for the day is number 7 from the textbook, page 256. Please pause the video, do it. When you're ready to continue, hit play, and we'll continue. We'll go through it together. Okay, so you see it uses the same information that we used in the example we did. It says, suppose in that example, the website charges a total of $1.99 for the first 5 songs you download, and 99 cents for each song after the first 5. Is it reasonable to use direct variation to model this situation? So this is more of a thinking problem. So if they charge you $1.99 for the first 5, and then 99 cents for every song after that, would that be direct variation? Would buying each song give you the same slope? And the answer is no. You definitely would not get the same slope. Because if you buy the first 5 for $1.99, where do I want this? Okay, so buying songs 1 through 5 costs you basically $2. And then song 6 costs you $1. Song 7 costs you $1. Song 8 costs you $1. So each of these is $1 a piece. Here, they're not $1 a piece. So each song is not going to give you the same cost, which means you're not going to have the same slope. Each song is not the same cost. And that's what it would take to be direct variation. Each song would have to have the same cost, so that way the cost to number or cost to song ratio would be the same, and that would be our slope. It doesn't work out. Okay. Lastly, here summary. What is direct variation, and how do you find it? If you can answer that question, it means you understood what the lesson was about. If not, you might need to go back and watch it again. Quickly though, pause the video, answer this question as best you can, hit play when you're ready to continue. Okie dokie, let's see here. What is direct variation and how do you find it? Direct variation is a direct relationship between the x and y variable. I'm sure nobody out there thought of that same definition as me, but that's okay. Direct relationship of the x and y variable. Now, more than likely stuff you folks put would be direct variation goes through the origin. So direct variation goes through the origin. And the constant of variation is the slope. That's really what we talked about for most of this lesson. We saw how every single problem here, if it was direct variation, it went through the origin when the y-intercept is 0, and then the constant of variation was the slope of the line. Okay? Here is the homework. It comes from pages 256 through 257, numbers 3 through 36, multiples of 3. So that's about 10 questions or so, 12 questions. You'll probably need some graph paper. This has been lesson 4.6. Thanks for watching.